What happens when a star dies? You might think it's the end, but in the cosmos, death is just the beginning. Imagine celestial titans collapsing, exploding, or fading away, only to become the cosmic dust that builds new planets, new stars, and even us. Prepare to have your mind blown by the universe's most dramatic recycling program. Every star's journey begins with birth. But what truly captivates us is their dramatic exit. It's a cosmic ballet where the final act is the most breathtaking. From quiet fades to explosive finales, how a star dies depends entirely on its size and initial mass. Think of it like this. Smaller stars go out with a whisper, while the giants go out with a bang. This isn't just an ending, it's a spectacular transformation, setting the stage for everything that comes next. The universe doesn't waste a thing, and the death of a star is the ultimate act of giving back. Let's start with stars like our very own sun. Their end isn't a violent explosion, but a graceful, slow surrender. As they run out of fuel, they swell up, becoming what we call a red giant, expanding so much they might even swallow their closest planets. Eventually, their outer layers gently drift away into space. These expanding shells of glowing gas create some of the most beautiful sights in the cosmos, planetary nebulae. They look like ghostly, colorful bubbles floating in the void. What's left behind at the center of this cosmic artwork is a small, incredibly dense core called a white dwarf. It's the smoldering ember of a once mighty star, packing the mass of our sun into an object the size of Earth. It's the stellar equivalent of a diamond in the rough, slowly cooling over billions of years. A quiet monument to a life well lived. Now let's turn up the drama. What about stars much, much bigger than our sun? Their demise is anything but gentle. When these stellar behemoths exhaust their fuel, they don't just fade away. They go out in a blaze of glory known as a supernova. This is one of the most powerful explosions in the universe, an event so bright it can briefly outshine an entire galaxy. After the cosmic fireworks fade, the explosion can leave behind an incredibly compact object called a neutron star. These things are the universe's ultimate speed machines and masters of density. They are so dense that a single sugar cube of neutron star material would weigh billions of tons here on Earth. That's like cramming the weight of every single car on the planet into a space you could hold in your hand. Many of these neutron stars spin at incredible speeds, hundreds of times per second, sweeping beams of radiation across space like a cosmic lighthouse. When these beams point towards Earth, we detect them as regular pulses, earning them the nickname pulsars. But what happens when a star is so massive that not even a neutron star can withstand its own collapse? This is where we enter the realm of the truly mysterious, the ultimate cosmic vacuum cleaners, black holes. For the most massive stars in the universe, when they die, their core collapses under its own immense gravity with unstoppable force. It keeps crushing down, smaller and smaller, until it forms an object with a gravitational pull so intense that nothing, not even light itself, can escape. This point of no return is called the event horizon. Crossing it is a one-way trip. For decades, black holes were purely theoretical, ghosts in our equations. But thanks to incredible breakthroughs, like the Event Horizon Telescope, we are finally piercing the veil. We now have actual images of a black hole's shadow, giving us our first real glimpse into these previously invisible giants that silently shape the galaxies around them. So, we've seen stars fade into white dwarfs, collapse into neutron stars, or become black holes. But what about all that material blasted into space during these events, especially from supernovae? This is where the magic of cosmic recycling truly happens. The supernova explosion acts like a cosmic delivery service, scattering all the elements forged inside the star's core across the galaxy. These aren't just simple elements. We're talking about the heavy hitters like oxygen, carbon, and iron, the very building blocks of the world around us. This stardust mixes with interstellar gas and dust clouds, enriching them. Over millions of years, gravity pulls this enriched material together, creating new nurseries for stars and planets. The iron in your blood, the calcium in your bones, the oxygen you breathe, it was all cooked up in the heart of a star that lived and died long before our solar system ever existed. We are, quite literally, made of stardust. This universal recycling program is an eternal cycle. The death of a star isn't an end. It's a vital and beautiful step in the universe's ongoing story of creation and evolution, ensuring that from the ashes of the old, the new can always rise. The cosmos is a place of endless wonder, where even an end is a new beginning. Thank you so much for joining me on this journey through the stellar graveyards of our universe. If you enjoyed this and want to explore more cosmic mysteries, don't forget to hit that like button, subscribe, and ring the bell so you never miss another adventure. And as always, keep looking up.